Hi, I'm Chris Manning, here to answer your questions on artificial intelligence. Let's see what I've got. What are foundation models and how are they useful? Foundation models is a term we coined at Stanford to characterize the class of huge new artificial intelligence neural network models that have been released recently and are so influential. But the idea was that the same idea of having models that were just trained by seeing a ton of data from the world could be applied not only to language, but also to vision, genomic sequences, robotics, other signals like radar, and that by having large neural networks see an enormous amount of data, they can get to understand a lot about the world and a lot about human languages if it's human language data. These foundation models now give us computer models with much more understanding, which are being widely deployed and reinventing what we can do with artificial intelligence. How is AI limited by hardware, energy consumption, the cost of LLMs, and what can be done about it? Good question. I think you can turn around the first part of it and say that a large part of the dramatic recent advances in AI have been powered by great increases in the amount of available hardware and the amount of available data. And yes, that does use quite a bit of energy, but it's really having these powerful parallel processing chips, GPUs, and lots of digital online data that have allowed us to do so much in artificial intelligence. I mean, as to what can be done about it, well, people are hard at work on all the different dimensions of this. So absolutely, people would like to design better processors that require less energy. Beyond that, I mean, there's a lot of work that's been done by the big cloud providers to get renewable energy sources for their data centers. So, overall, even though these systems do use significant amounts of energy, they're really not as bad as taking your international plane flights for your vacation. As to how we can build models that use less compute and less data, a brain uses extremely little power, right? We run on way less than an LED light bulb. It suggests that as well as working out better computer technologies at the hardware level, what we should be trying to work out is better ways of doing machine learning that can learn more with less data. It seems very clear that human babies can learn significantly more from a limited amount of data than our machine learning models yet can. But, that means there's still exciting things to do in artificial intelligence research. Let's see. How can we improve explainability of AI models? That's a question that many people have been interested in. There are two sides to that. One side is to say that perhaps it's okay to have AI models that aren't explainable, providing they do the right thing. After all, humans make lots of decisions, and a lot of the time they can't really explain why they thought one way or the other. It was their hunch or their sixth sense that it felt like this thing wasn't genuine. But nevertheless, there are lots of contexts, whether it's in legal context or medical context, where you'd like to have explanations. And so there's a lot of work in trying to make models more explainable. And I think there are two fundamental levels at which that happens. At a low level, you want to be able to interrogate a neural network and decide which features of an input are causing it to make a certain decision. And there's plenty of work that's doing that. So there are methods like LIME that was pioneered by Carlos Guestrin here at Stanford that are looking at those kinds of explainability in neural networks. But I think a lot of the time, once we move to very large neural networks, we'd like a higher level of explainability, that the neural network can actually just tell us why it is making a certain decision. And I think that's a capability that we're actually approaching with large language models, that large language models can often give a quite good explanation as to what are the features that lead them to certain decisions. Okay, in the future, will AI be so smart it won't need human input? That's a good question. And I think the honest answer is no one knows. There is a conceivable world at some point in the distant future where an AI system can just learn everything it needs from the world around it, and it doesn't really need us to tell it things. But I think there's also a lot of very heated hype at the moment. You can see lots of predictions that artificial general intelligence is just around the corner. Some people think that by 2030, there'll be computers that are better than human beings at almost all tasks. I think a lot of those views are fairly irrational exuberance where people have been getting a little bit too excited by the very genuine big advances we've made in the last few years. They have, if you will, drunk a little too much of their own Kool-Aid. So on the one hand, there's no doubt at all there have been really exciting advances, and there are many ways that computers, such as large language models, that have ingested just huge amounts of text, billions of web pages, all of Wikipedia, just know a lot more than humans do. But there are other ways in which humans' knowledge and ability to operate in the world is likely to be better than our AI models for a number of decades to come. Okay, I've completed the basics of machine learning and deep learning. What should I learn next? I don't think that's a question that has a one-size-fits-all answer. I mean, one answer is that maybe you should apply some of the knowledge that you have learned. I mean, I think it's just a great next step to find a project that's something that you're really interested in. It could be something at work, or it could just be something that's completely an interest of yours as a hobbyist thing, working out something for, rating wines or something. So, spending more time actually building AI application from beginning to end is still a huge further learning exercise after doing one or two of our classes. But there are lots of other great classes you could do, and I think at that point it depends more on what you're interested in. So for example, if you're interested in human languages, do the My Natural Language Processing course. On the other hand, if you're more interested in robotics, say, and ideas as to how you can have robots respond to events in the world, then maybe you want to do the reinforcement learning course. If you're interested in something like relationships between genes and drugs and proteins, well, maybe that's graph neural networks as the next step. I think you really need to think about what would be useful and interesting to you. Okay. Will conversational assistants and chatbots replace search engines? That's a very topical question. I think there isn't a single answer. I think search is actually a multifaceted thing, and there are different answers for different kinds of searches. So maybe I can choose three cases. So one case is that people just have a particular question in mind. So my question is, whatever it is, when is the primary going to be held in the elections for California, or who is Beyonce married to, or something like that? Well, to the extent that I've got a question like that, yeah, absolutely. I think we're already at the point right now where conversational agents, LLMs, are great for that sort of purpose, that they're faster and better than something else you could use. You can also use them for all kinds of other question answering related purposes, some that you might not expect. So, if you're looking for a hotel recommendation for your next trip to Oregon, actually you can do that very well if you just like to be suggested a hotel that a model thinks would be good for you. But there are also a lot of other ways that people use search. So sometimes people use search when they want to take a deep dive themselves, right? They're buying a new tent and they'd like to read, 20 pages of reviews of different tents by outdoor enthusiasts to make up their own mind. Well, to the extent that that's what you want to do, no, you want to use a search engine that can give you a list of pages that would be good things to read about reviews of hiking. And then a third case that's actually surprisingly common is what people in search just refer to as navigational queries. There are lots of cases where people are making a search like Honda Odyssey, where they just want to be taken to the page about the Honda Odyssey to read about it. So it's not really searching for information, it's really just wanting to be navigated to a web page, and that's obviously not going to be covered by using a large language model. Perhaps a better example of that is when you want to do something transactional, like I want to check my bank balance, and I just put Chase Bank into the search engine because it's just easier than typing the URL. Okay, what motivates you despite the hype and occasional negative comments? Well, I think that one has a really easy answer, which is that this has been just such an exciting time in artificial intelligence. I've been involved in artificial intelligence for about 30 years, and all through that time have had a feeling that yes, we've been making progress, there have been scientific advances, there have been new ideas for how to build systems, typical gradual scientific progress. But the reality was that for the majority of that time, systems didn't work that well, progress was kind of slow, there weren't really applications that were good enough for human beings to use for many purposes. In contrast, the pace in the last 5 years has just been astounding, that it seems like, every month or two, there's some dramatic new advance in systems and their quality. We have amazing language models that do such a good job of answering questions. There's been rapid progress in generative AI for doing things like creating images. We're starting to see that even generative video is becoming possible. Great work has been done in understanding the structure and folding of proteins using artificial intelligence. Lots of other applications in all kinds of places. So there's just been this huge amount of optimism and excitement from everything that we can now do, and the whole world has become excited by some of these things. I certainly don't want to deny that there's hype around artificial intelligence. There's a lot of hype at the moment of people making very strong and wild claims of how fantastic things are or how fantastic they'll be in 3 years' time. But this isn't an empty hype machine. This is something where there's exuberance on top of a field that really is making dramatic advances. So I focus on those dramatic advances, and it's easy to stay optimistic. Now, there's also considerable concerns about artificial intelligence. There's concerns about the systems as to whether they're biased against different groups, such as different ethnic groups. There's concerns about whether the systems will have bad effects, such as that people will lose their jobs to AI systems. And furthest out, some people beat a drum where they're saying that these AI systems will become so intelligent and good that they'll be a danger to humans. I think those are different problems, and they're all important to think about, but they have different responses. So relative to the question of AI systems being biased in various ways, that's a really genuine concern. But it's also an opportunity for research. So there's considerable research work now, including at Stanford by some of my colleagues, such as Tatsu Hashimoto, on how can you design different kinds of learning algorithms which suffer less from the tendency of being biased to work only for the majority subpopulation of a population. So hopefully a lot of those things can be at least lessened in time with improved data and improved machine learning. The problem of some people losing jobs is a serious and a real one. I mean, that's happened throughout time, going back to, a period when nearly everybody worked the land, and gradually there started to be more automation on farms. So I think it can be difficult for individuals when their jobs change. They have to learn new things. They perhaps even have to train for a different job. But I think that's been the nature of the advancement of humanity and society as well. And so the main pressure there is on trying to make it easy for people to find new roles in a changing world. Then there are some people that do what some people call critty hype, of greatly hyping these super intelligent science fiction AIs that somehow are going to develop the goal of wiping out humanity. I think that's unrealistic on a couple of levels. Firstly, I think we're a very, very long way from having the technology for any such thing. You know, we still just don't have very good robotics technology for things to move around the world and control things the way that human beings do so fluently. But beyond that, I mean, there's just absolutely no reason to think a computer has any particular reason to wipe out a human being, that our computer systems just don't have the same basal evolutionary strategies of, you know, competing for food in a human world. So I think there's a lot of projection and fantasy there, and I don't actually think that that's something we need to worry about a great deal. Okay. What's the next big thing after large language models? There's an easy answer to that, and then there's a hard version of that question. The easy answer is to say, well, the technology of large language models, which was essentially we could take a piece of text, blank out some amount of it, and then say, given the start of the sentence, what will the next word be? Try and predict it, learn if you get it wrong, and then just repeat over billions of times. That strategy of, well, what's sometimes called unsupervised learning or sometimes self-supervised learning, since you're sort of making your own learning game, you can repeat that strategy in other areas. So you can take a picture and blank out bits of it and try to predict what's in the part that's missing. You can take a gene sequence and blank out a piece of it and try and predict it. So this is then a very successful strategy that can be used for all sorts of other domains of human experience and science, and that leads to the generalization that we call foundation models. So we're going to see a lot of broader use of foundation models in the soon nearby years. But there's a harder version of that question, which is to say, if large language models aren't everything you need for artificial intelligence, what else do you need, and how can you successfully build it? Most people think you are going to need some other things, that even though large language models have been incredibly successful, they don't really seem to build the kind of world models that human beings have, where they have a sense of stuff in a physical world and particular entities, human beings, corporations and their relations, that's more abstracted away from particular sequences of words. And so that suggests we need some kind of different model of artificial intelligence that allows us to build that successfully. And that's something that, you know, people are absolutely working on, and, you know, people have been looking at things like graph neural networks. But I think it's fair to say no one really knows the answer of how to do that successfully. And so that's why we're still doing academic research. How do I increase my understanding of AI beyond off-the-shelf packages? I've got the answer to that one. You have to build things. It's a really good learning experience to actually work on building things for yourself. I mean, many of the most capable AI practitioners just put effort into building things for themselves, re-implementing things. You know, one great example of that's a Stanford PhD grad is Andrej Karpathy. So Andrej's had a career first working at Tesla, and now he's back at OpenAI. But, you know, he's also just a weekend hacker who likes to build things. So, you know, just recently he's written a sort of a little implementation of large language models, mini GPT, you know, completely from scratch. And the reality is that just by building things for yourself from scratch, even if they replicate something that someone has done or a big framework from a tech company, you just learn so much, and that's always a great exercise to work through. Okay, will classical AI and machine learning algorithms be usable in the age of quantum computing? That's a hard one. I'm really not an expert on quantum computing, but honestly, at the moment, I see no danger at all of quantum computing capabilities displacing what we're doing in AI and machine learning. That at the moment, people are still struggling to build really small quantum computers. So those really small quantum computers can be used for things like cryptography, and the fear is that because of their different nature, then they can break the kind of cryptography that we all depend on at the moment, both to keep, our banking transactions and government secrets secure. But you can only build small quantum computers, and precisely all the action at the moment in artificial intelligence is building huge neural networks. And so our quantum computers are, a million times smaller than the kind of neural networks we're building now, and they appear to be very difficult to scale. So I think there's sort of no foreseeable future where quantum computing really changes or stops what we're doing in artificial intelligence. Okay. What are some promising new career paths within AI? So there are lots, right? We're still at a stage in which there's just a huge shortage of machine learning engineers and a huge shortage of people with a good understanding of neural networks, natural language processing, and robotics and related technologies. So that if you get good skills in these areas, there are all sorts of things that you can do. One caution, it's hard to know what will happen in the coming years, but clearly the very biggest tech companies have had a certain bit of indigestion over the last year or two, that for a while they were hiring up every machine learning engineer they could find, often paying them humongous salaries, and then they've decided that, maybe we have been just hiring people because they're available and we thought we should try and corner the market. And so they've really pulled back in hiring in AI, but also in other areas. But, the flip side of that is there's every other kind of industry, whether you're thinking something like other players in the car industry, people in banking and finance, people in construction, people who'd like to automate mining or agriculture. Anywhere you look, there are lots of applications now where there are ways that you could use artificial intelligence to reinvent different industries, and nearly none of those have been explored and built. And so I think there's just an endless need for and opportunities for people using machine learning. In my spare time, I also do some advising of companies, and you sort of see that in all sorts of places, right? So there are little startups using deep learning for weather prediction. They're using deep learning to predict better diets for cows so they don't burp so much and release so much methane into the atmosphere, doing robotics, having drones flying around factories so you can monitor the levels of different supplies without human beings need to run around the factories. Everywhere you can think of places where we can now have more automation, and that's going to be using artificial intelligence technologies. What are some key challenges in the field of natural language processing? In some ways, that's become a harder question than it was a few years ago, because large language models were the first huge success of this new style of self-supervised learning that we're doing. And sometimes, even to me, it almost feels like natural language processing is solved, that a lot of the things that I used to spend all my time doing not very successfully, such as getting information out of text documents, finding facts, like for some company, how much pollution did they release, what was their profit or loss, who's their CEO, right? That getting things like facts out of documents used to be just extremely difficult to do well. Whereas a lot of the time now, you can use large language models and they just work fantastically well. And it seems like we can do natural language. But, the reality is that that's still very partial. I mean, we have sort of working machine translation for large, widely spoken languages, but, there's still opportunities for it to get better. But, also there are a lot of things that then harder in machine translation. As soon as you move away from English, Chinese, Hindi, German, right? You're moving into a lot of smaller languages, whether it's smaller European languages like, Danish or Swedish, or smaller languages from other parts of the world, an African language like Sesotho, or a smaller Indian language like Marathi or something like that. I mean, for none of those languages are there good machine translation systems, and it's harder to build them because there's much less data available. When it comes to doing things of generating text, if you just want to generate text that reads fluently, you can do it really well now. But if you're actually wanting to generate text, or indeed to generate images that express a particular point in a particular way, we still have not as much control as we'd like to have. For building conversational systems, maintaining an understanding of both the person you're talking to and their context, we're still not very good at that content maintenance either. And then there are lots of the problems that we were talking about earlier, things like bias in large language models, explainability of large language models. So there's still tons of different areas to address in the future. I'll just finish with one interesting new direction that some students are working on at Stanford, which is how do we build the next level up from large language models? So if you're actually going to be building full applications with large language models, it normally just isn't going to be the case that you've got one large language model and you're done. You're actually going to build lots of components around your large language model, because maybe there's going to be one large language model that generates some ideas for a story. There's going to be another large language model that generates a script based on that. That'll be interrogated by a third model, which checks to see if there's gender bias, and if so, revises it. So you're actually sort of building a program out of large language models. And that's an exciting new higher level domain that we're just beginning to explore. Here are a couple of AI-generated questions. Considering the rapid progress in NLP, what key factors and actions should the community prioritize for responsible and ethical AI language model deployment and development? Well, it's really good to know that the AI systems are also thinking about what's important for responsible and ethical AI language model deployment. So there are lots of things to think about there. We certainly want systems that don't exhibit conventional gender biases or ethnic stereotypes. The fact of the matter is that all of the current large language models do exhibit those problems. It's a combination of two things. In part, it's because these models are just trained on a lot of historical data from the world. And well, what they see is that nearly all politicians in the United States are white males. And so they develop the stereotype that a politician is a white male. One of the things that human beings are better at is having in their head how they think the world should be, rather than just knowing how the world has been and having statistics based on that. But there are also details of the machine learning models where they tend to emphasize majority cases and forget about the minority cases. So we should be working out how to build models that do a better job of that. But we should also be trying to get data from different sources so it represents different groups. And we should have the preferences of different groups involved in the evaluation of models, finding their weak spots, teaching them how to behave. So a couple of people at Stanford have been involved in this idea of jury learning, Professor Michael Bernstein and his students. And the idea there is that there isn't sort of one right answer to how you should behave in many contexts, that different subgroups of people have different impressions. And so you actually want to represent a jury of your peers and how different people feel about things. And for some things, you want to be sensitive to minorities and their interests, even if the majority of people don't find something offensive or mind it. And so lots of things to explore in those areas. Okay, AI system asks, what are some of the most promising and exciting real-world applications of NLP that you foresee emerging in the next few years? Tons. So I think we're going to see a lot more NLP systems being deployed very successfully everywhere. So a lot of websites already have a little AI assistant in the bottom corner where you can chat to the AI assistant about the company product or things like that. At the moment, they sort of work, but they're not really that great. At least I don't find them that great. I think we're going to see a new generation of ones powered by large language models, which really work much more fluently. I think we're going to see much more use of conversational assistants. I mean, some people think it's a horrible prospect to imagine people talking to an AI assistant rather than another human being. And I'm not wanting to say that we don't want humans talking to human beings. Of course we do. We need much more community than we have in the current modern world. But it turns out that there are lots of people who would like to get feedback from somebody or something that can give human-like responses and don't always have the right human being standing by. So you're thinking about how to word an email to your boss, or you're not quite sure what you should say to your boyfriend. It turns out that you can get advice, drafting help, suggestions of what to say from a large language model that are actually useful these days. But, once you move out from there, I think kind of there are all sorts of job functions which now a large language model can help you with. And I think most of us just haven't thought enough about what the models could do. So, next time if you've got some writing assignment, whether you're wanting to post a job advertisement or write, your monthly status report, I encourage you to try it out. Rather than trying to write it all for yourself from a blank page, maybe just write 6 bullet points and say, hey, large language model, can you write a monthly status report around these points? And I think you'll be surprised at how good it comes out. To take one more example, my colleague at Stanford who does bioinformatics, Anshul recently reported that he just took a vacation to Europe with his kids. And the way he found all the hotels to stay at in Europe was by asking a large language model for recommendations. And he was amazed at how good the recommendations were. And when things went wrong on the plans for the trip, because, kids, they do different things and they might be tired or not want to do stuff, he asked the large language model, gee, what could I do instead this afternoon? And he liked the answers it got. I'd honestly never contemplated doing that. I went on a vacation this summer as well, and I did it the conventional old way of doing searches, looking at websites, etc. I think there's just a whole world of ways that we can use these models because our world is so language-based and that we're all just sort of exploring what some of the possibilities are.